So audio is okay. Finally, we have planned a short session to reflect the lessons learned of our project. Therefore, we have extended now our round, and the format will be that every partner representative can give his own opinion on this contribution to the energy transition. And yeah, so it's a free discussion, starting with Stefan. Do you like to start for that, for example? And yeah, we are limited in time, so we quickly go through it. Yeah.
Thank you. So as I was mentioning in my talk, Ethan was involved in two areas. One is the MVDC, and we were collaborating briefly with HYPERRIDE. Practically, HYPERRIDE is developing a more mature and more developed circuit breaker for 5 kilovolt, and is actually all the way to testing in Aachen. In our case, we are looking at a higher voltage, slightly different use case, but we are much earlier in our direction. So practically, we have some lesson learned from that. It's very important to at least in MVDC, where you don't have a lot of ready products, commercial products. It's very important that you are actually using the existing technologies, but at the same time, the scaling up is not straightforward. So a certain technology can be taken forward by the owner of the technology. So, for example, HYPERRIDE can spend the time to develop for 14 kilovolts, as we were mentioning, but at the same time, the competitive landscape in industry is practically says that the competitors, the companies that are working in this direction, will also have to take into account own ideas, as we have some own ideas that we are working on. And this is actually will come with its own set of challenges. So it needs the lesson that we learned in this is that the development of a medium voltage circuit breaker, even if you have experience in low voltage DC circuit breaker, we have in Eton some experience in the direction, is still a lengthy and a challenging project that needs to be taken into account. This being said, we will by the end of the project, we will show our proof of concept, and we will demonstrate in laboratory measurements, but this will be much less in terms of technology readiness level than the solution that HYPERRIDE is demonstrating. And this is in one of the directions. The other direction is the low voltage DC. In this case, we are a little more advanced, as I was mentioning. We have several projects in which we are involved with low voltage DC. So we have certain experience. We have corrected a lot of challenges. I mean, we have approach a lot of challenges and tackle them for the low voltage DC distribution. However, even if what we learned from the practical demonstration, and we have here Massimo as a witness to this, we have learned that actually unforeseen challenges, unforeseen problems can appear in the practical implementation. Even if you are trying to repeat, you are saying, okay, we have developed this, but we also want to implement again very similar solution in a different setup that can actually prove challenging as well. The evolution, the continuous evolution of the technology. So being a new DC microgrid and DC components are fairly new on the market. So the providers are continuously developing and producing new versions, and that is actually posing a challenge. So all this needs to be taken into account when going for a practical demonstration. Even though, as I was mentioning before, we have some experience with that. We have worked with the power system and control in several use cases and pilots. There's still a lot of challenges. So practically, we can confirm that the development of commercial ready solutions is not an easy task, and it in a way justifies what the evolution of and penetration of DC power system is slower than we would like. And I think this is our main challenge in the two directions, our main lesson learned. So we can discuss more if you have particular questions about this, but I guess I can now give the give the microphone to somebody else.
Yeah, thank you very much, Stefan, for your opinion or your feedback from a big manufacturing side. Happy to have you on board, and yeah, maybe I can continue with the technical issues and university archi side.
Yes, Stefan, actually, I would like to continue your statement more or less, because the lessons learned on RWTH Aachen side are that, I mean, first of all, it's possible already today to operate hybrid AC/DC, and even medium voltage to low voltage DC substations. But the focus in the future should be to develop and implement systems that are set up for multi-vendor interoperability. So what we achieved in Aachen was to adapt all of the converters that we had, to adapt all the controls and all the communication to achieve interoperability for our system. What we need to ensure that we can develop and implement systems that are interoperable in the future without touching every control aspect or every measurement. So with that being said,
yeah, thank you for this. I can only confirm, yeah, as a standardization is a big issue for the future, starting with LVDC, but also in the next step on MVDC levels.
Yeah. Do you want to answer more on this aspect of?
Yes, in the low voltage is the key in the revolution, I think, because if we, the key word is smart grid. Smart grid is, I think, an approach, a different approach in the concept of distribution, because the smart grid already exists many years that it exists in high voltage to regulate the frequency and the connection in all the European countries already exists. So the smart grid in high voltage exists. It doesn't exist in medium and low voltage. And fuel electric home and energy community and prosumers, aggregators, all these words speaks about the users and the small producers, the private, the citizens that must participate in managing the energy. And in this approach, in this new approach of market, but not only, also cultural approach, in participating the citizen in the energy managing, it passes through, I think, the hybrid, because converters and are amazing devices that burns native digital. In the distribution, in the low voltage, we have a circuit breaker, very easy. And we have some controllers, and we have also smart meters that acquire the measure every 15 minutes, but the 15 minutes is very too long time to manage energy. And in DC, we can use the fine tuning in converters, and the match is between the transformers, the AC transformers, and converters. In converters, it wins because we have many possibility to get measure in real time to fine tuning different. If I have to change energy in AC, I have to have an outages and to go there in the substation, and with the screw, I change the connection physically, and we come back to smart grid, and this is, I think, the loop that make the hybrid AC/DC grid the winner for the future. If we solve the problem that Stefan told, but are less problem because many years ago when I degreed at the university, the problem was the interruption of the DC current that